Hello guys, welcome to our next video in the playlist Google Earth Engine for the land cover applications. So in today's video, we will learn about how to uh, know the unsupervised classification using the k-means algorithms in the Google Earth Engine. So this will basically classify any land cover into the classes which we'll give, and it based on the cluster algorithms. So let's start. It doesn't have any kind of training inputs as we have already seen in the supervised classification. So let's start by defining a region of interest as usual. So I'm creating uh, geometry. So let's cover the geometry. Okay, so rename it as region of interest, and you can uncheck this geometry. And I'm using the sentinel data as usual with the 10-meter resolution. So let's import the harmonized sentinel to multispectral instrument level 2A. So rename it as S2. So let's once again look at our data set. So open the data set. Here you have the bands, 10-meter resolution, and you also have the scale. So in order to conduct any analysis for any region using these bands, so we need to multiply each band by 0.001 so that our analysis will be more accurate. So let's do that using the function. So let's create a variable called pre-image. So in this, we are selecting the Sentinel-2 data and filtering it to our region of interest using the function filter bounds to region of interest. Then we are filtering to date to latest 2024, uh, January to 2024, say October 30. So close the brackets, and after that we should also filter the cloud using the function filter metadata. So go to the Sentinel data and go to image properties. Here you have this property called cloud pixel percentage. So it's unit array in percentage. So this has been basics now. We should know how to filter a cloud. Then we should give the argument as less than, let's say, 0.1%. So this function filters the image collection for the date 2024 January to October 30, and to our region of interest, and with the images which are having the cloud pixel percentage less than 0.1%, so that there will be no noise in the image. So let's print this variable to see how many images we have. So remember, it's a image collection, it's not an image. We need to reduce it to an image after filtering. So print pre-image, click on the run. So our image collection is loading. So here you see we have 579 elements which are having the cloud percent of less than 0.1% for our region of interest. So it's pretty good number. So let's apply our scaling factor to the image by creating a new variable image is equal to select our pre-image which we have filtered, and use the function dot map in order to apply the same function for all the images which are consisting in this image. So we are creating a function called it takes the input image and open the flower brackets in order to define uh, image, in order to define what it should work. So we are have to give the return the image get multiplied by our scaling factor, which is 0.001. That's it. And now reduce it to an image using the function median and clip it to a region of interest. So I will clearly say once again. So we have created a function for the pre-image filtered image collection, we have created a function which takes the image as an input and returns an image which multiplied by 0.001, which is our scaling factor for all the bands. And then we have used the median function to reduce the image collection to a single image, and we have clipped our pre-image into our region of interest. So the filtering as well as the clipping are two different functions, so you should be careful while doing this. So let's give it a run. We have no error, so let's add this to our layer using the map.addLayer function. So add image, let's say minimum will be 0, and maximum reflectance value will be 0.3 for the sentinel. Usually after getting multiplied by its scale factor, so we should also select the bands. So I'm taking the true color composite with the red and blue. For RGB we are taking RGB only, 3 2 1 red, green and blue. So we should rename it as true color image. So let's give it a run. So before giving run, you should also set the background to map.center object. So this will automatically zoom into our region of interest, and the zoom level will let it 14. Let's give it a run. So 14 is too zoomed, so let's reduce it to, we have a bigger region of interest. Okay, so we can reduce it, the process will be much faster. So if we can reduce it, so let's create a one more variable, click on OK, and we are taking only this much. Okay, so now you can delete our earlier region of interest, and you can rename it as ROI. So no need to change any script, we have just changed our region of interest. Uncheck this geometry, now click on that. Yeah, so use the inspector column in order to know the precise zoom level. So here you can see, oh, the zoom level is 10, so let's change the zoom level to 10. That's it guys. So we have an image which has the cloud percentage of less than 0.1, and which is a mosaic of 793 elements, that is the images, and we have added our true color image to the map. So let's start the supervised unsupervised classification. So we have an image, so let's start by creating a variable called clusterer is equal to, so we are using the function or the algorithm which is called as ee.clusterer dot beaker k means. So this is the algorithm which we are using, and you can simply give control plus space button in order to know which are the arguments which are needed in order to run this function. So it need number of clusters, so let's say it is 5. So we need only number of cluster, so let's say number of clusters be 5, and let's train this using clusterer.train function. So let's again click on the arguments which are needed. So we have features, so the feature should be from the image which we have imported. We should sample this image with the sample function, and you can click on the arguments which are needed. So define the region should be region of interest, and scale is let's say 10, and projection and all is not required. Factor number of scale pixels you can give to be 1e9, so it should not be a string, it's a number. So 1e9, and this is C drop null style scale and it's all not required. So you can give the geometries to be true in order to overcome the errors, and you just close the flower bracket. Yeah, and now we have this input properties, and this subsampling and all not required. So let's remove it. So close the brackets. So our cluster is ready now with 5 number of classes. So let's create one more variable called clustered in order to apply the clustering to this variable. So we have our image, and select the bands. So we have this image, so let's call it as cluster. The cluster is our cluster only, our earlier variable. That's it guys. So let's add this to image in order to know how our classifier has worked. So we are using again the map.addLayer function. We are adding the clustered variable to the map, create the visual parameters. So let's say minimum will be 0, and maximum will be 4, because we have the 5 number of clusters. It starts from 0, so 0 to 4 will include the 5 classes, and you can have the palette which we should give 5 colors. So let's say red, blue, you can give anything, green, say gray, and uh, we'll give yellow. So we can change the palette later. So now you can rename it as unsupervised classification, simply unsupervised. So let's give it a run. Yeah, our two layer is loading. I think we don't have any kind of error. So this is the true color image, and our cluster is still loading. Our unsupervised class is still loading. So I think it's taking some time. So yeah, we have an error. Computed value is too large. So let's select the bands in order to have the low computed values. So you can go to our image. You can just rename it as filtered image, and create a one more variable called image is equal to, from this filtered image we are selecting the bands. So it should pass in a list. So I'm selecting the blue band, green, red, near infrared, shortwave near infrared, and one more shortwave near infrared. So I think this much is enough. So let's give it a run again. So one more error is there. So let's reduce our region of interest again. So we can delete this and create a small region of interest. Let's say this much. Okay, and rename it as ROI, not gaps. It should be small. So it should work now. We'll see. So we are getting the error again. So let's change this number of pixels to minimum number of pixels. Let's say 5000 pixels and give it a run now. So it should work. Since our region of interest and the pixel size is very much less, yeah, it's loading now. Here you can see how clearly our supervised unsupervised classification has worked. So let's zoom into any region. Let's compare what it has classified. So you can switch to satellite mode if you want, and you can uncheck the labels, and you can also uncheck the true color image in order to have the better visualizations. So I think one in the green colors are the river, and one in the blue are the forest regions, and one in the yellow are the barren lands, and one in the red are I think it's dense forest, and yeah, one yellow is stands for the barren land. So that's it, guys. We have the five classes here. You can see from 0 to 4, and we have the five palette. So this is how we can classify any land without any training inputs. So we are just using the clusterer algorithm with the k-means k-means clusterer algorithm in order to classify any region without training inputs. So I hope you have understood how to do unsupervised classification. So only thing you need to keep in mind is our region of interest, how big it must be, and the number of pixels. So in order to avoid any kind of error. So I will also provide the code link in the description box. You can have the direct access to this script. So that's it, guys, for today. Thank you for watching.